A hydrogen project usually starts with something very simple, an idea. Maybe you have identified a location with strong solar or wind resources. Maybe there is an industrial company nearby that could potentially use hydrogen. Or perhaps you are trying to understand whether a particular country, port, industrial zone, or energy hub could support a commercially viable hydrogen project. But an idea is not yet a project. Between the original concept and an investable infrastructure project sits a long development process involving site selection, electricity, water, electrolyzer technology, storage, transportation, customers, economics, financing, and risk. This is where H2Hub comes in. In this walkthrough, I'm going to show you how H2Hub can help take an early hydrogen idea and turn it into a structured project development case. We'll move through 7 steps, from defining the idea and screening the site to generating a system concept, testing project economics, understanding risk, and creating an exportable project narrative. One of the biggest challenges in hydrogen development is not necessarily generating ideas. There are thousands of potential hydrogen concepts around the world. The challenge is turning those ideas into something structured enough to evaluate. A developer may have information about renewable resources in one place, electricity costs somewhere else, water availability from another source, electrolyzer assumptions in a spreadsheet, and potential customers in completely different documents. Then there are questions about infrastructure, permitting, transportation, financing, and policy. Very quickly, the project becomes fragmented. Another problem is that there is often no obvious development sequence. What should you investigate first? Should you select the electrolyzer before studying the site? Should you calculate hydrogen costs before identifying the likely off-taker? How much information do you need before talking to investors? And finally, there is the problem of proof. Partners, lenders, investors, and potential customers need more than a good hydrogen story. They need to understand the assumptions behind the project and what still needs to be validated. H2Hub is designed to organize this messy early stage into a more logical development workflow. The easiest way to understand H2Hub is this. H2Hub helps turn an early hydrogen concept into a structured project development package. Instead of treating education, project screening, engineering concepts, and economics as separate activities, the platform brings them into a connected workflow. The process follows 5 broad actions. You learn, you screen, you build, you test, and you export. For example, you may begin by learning how a hydrogen production system works. Then you screen a potential site. Next, you define project assumptions and begin constructing the system. You test the economics and the major risks. Finally, you organize the results into something that can be reviewed or shared. The important point is that H2Hub isn't meant to replace detailed engineering, financial due diligence, or professional project development teams. Its purpose is to help you create a much stronger starting point for those conversations. Here is the complete H2Hub workflow. Step 1. Define the project idea. Step 2. Screen the site. Step 3. Establish the project assumptions. Step 4. Develop the system schematic. Step 5. Examine the economics. Step 6. Stress test the project. And Step 7. Export the project narrative. Notice what this process is doing. We are progressively increasing the amount of structure around the original idea. At the beginning, you might only know that you want to build a renewable hydrogen project in a particular region. By the end of the workflow, you should understand the proposed location, basic system configuration, important assumptions, economic drivers, major risks, and the next questions the development team needs to answer. Again, this is not detailed engineering. It is a credible first-pass project development case that can be challenged, refined, and improved. Everything begins with the project story. Before worrying about sophisticated calculations, define what you are actually trying to build. Where is the project? What will the hydrogen be used for? How large might the project be? Where could the electricity come from? And who might eventually buy the hydrogen or its derivatives? Inside the H2Hub workflow, the first objective is to convert a vague concept into a defined development case. You might enter a country or location, give the project a working name, establish an initial capacity, select the potential hydrogen product or application, and define the purpose of the project. For example, Suppose we want to investigate a 50-megawatt green hydrogen project, supplying hydrogen to industrial users. That is still a very early concept. But now we have something that can actually be investigated. This first step is important because every calculation that comes later depends on how clearly the original project question has been defined. Now we move from the idea to the location. Hydrogen projects are extremely location dependent. A project can have excellent technology and still fail because the site doesn't work. H2Hub's site screening approach helps you think about several factors together. What does the renewable resource look like? How close is the project to electricity infrastructure? What about water? Are roads, ports, pipelines, industrial customers, or other important infrastructure nearby? And does the overall location make practical development sense? This stage should happen early because site problems can become enormously expensive later. Imagine spending months developing an electrolyzer concept only to discover that transmission capacity is limited, water is difficult to secure, or the nearest viable customer is hundreds of kilometers away. Site screening helps answer a much simpler question first. Is this location interesting enough to justify deeper investigation? If the answer is no, you can examine another site. If the answer is yes, the project moves forward. Once the site looks promising, we need numbers. Every early hydrogen project is built on assumptions. How much electricity will the electrolyzer consume? What electrolyzer efficiency should we use? What utilization or capacity factor are we assuming? How much water will the project require? Do we need hydrogen compression? How much storage? Will hydrogen leave the project by pipeline, truck, or through another conversion pathway? And what assumptions are we making about capital cost and operating expenses? The important principle here is traceability. You should be able to see where an assumption came from and change it when better information becomes available. Early-stage project development is not about pretending that every number is certain. It is about clearly separating what you know from what you currently assume. That makes the model easier to challenge and much more useful as the project develops. Now the project starts becoming visual. A hydrogen facility is a system. Electricity comes into the project. Water enters the treatment system. The electrolyzer converts electricity and water into hydrogen. The hydrogen may then require purification, drying, compression, storage, transportation, or conversion into another product. The H2Hub schematic workflow helps organize these components into a logical system concept. This is extremely useful because project development involves people with very different backgrounds. An electrical engineer may immediately understand the power system. A hydrogen specialist may focus on the electrolyzer. An investor may care primarily about cost. An industrial customer may only want to know how hydrogen reaches their facility. A schematic gives everyone a common picture of the project. It allows a complicated infrastructure concept to be explained visually, while still preserving the technical logic behind the system. Now comes one of the questions every hydrogen developer eventually has to answer. What could this hydrogen cost? This is where the project moves into the economic stage. H2Hub can be used to examine the levelized cost of hydrogen and other important economic indicators using the assumptions established earlier. Electricity price matters. Electrolyzer capex matters. Utilization matters. Efficiency matters. Financing assumptions matter. Operating costs matter. And the revenue or selling price available to the project matters. The objective at this stage is not necessarily to produce the final financial model that a bank would use. Instead, we are looking for the project's economic signal. Does the project appear remotely competitive? Which variables have the greatest influence on hydrogen cost? And does the project look promising enough to justify additional development expenditure? This becomes an important decision point. Sometimes the answer will be yes. Sometimes the model will reveal that the concept needs to change. A hydrogen project should never be evaluated using only one perfect scenario. Projects operate in the real world. Electricity prices change. Equipment costs change. Construction schedules slip. Interest rates move. Capacity factors can underperform. Customers renegotiate. This is why stress testing matters. Instead of asking, does the project work under our assumptions? Ask a much more important question. What happens when those assumptions are wrong? H2Hub allows the user to examine some of the variables that commonly determine whether hydrogen projects survive. What happens if electricity is more expensive? What if electrolyzer capex is higher than expected? What if utilization falls? What if the project faces higher financing costs? What happens if the offtake price isn't high enough? Or if commercial operation is delayed? These scenarios help identify the project's critical dependencies. And that tells the developer what needs to be proven next. At this point, the original hydrogen idea has become much more structured. You now have a location, you have assumptions, you have a system concept, you have preliminary economics, and you understand some of the major project risks. The final step is to organize this information into a usable project brief. The report should summarize the project concept, site, technical configuration, key assumptions, economics, risks, and recommended next actions. This is valuable for several reasons. A developer can use it internally to decide whether the project deserves additional resources. It can support conversations with potential partners. It can help prepare for discussions with investors. And for students or new developers, the exported package becomes a practical learning record showing how the project was constructed. The real value is not simply creating a PDF. It is creating a coherent explanation of the project. Let's make this workflow concrete. Imagine we are evaluating a 50 megawatt PM electrolyzer project. The project would use renewable electricity and produce hydrogen primarily for industrial consumption. At the beginning of the exercise, that may be nearly everything we know. Using the H2Hub workflow, we can begin developing the concept. First, identify the potential site. Then examine electricity and infrastructure conditions. Next, establish assumptions for the 50 megawatt electrolyzer, power consumption, utilization, water requirements, storage, and other components. Then build the system schematic. After that, estimate the levelized cost of hydrogen. Finally, test the project against different electricity prices, equipment costs, utilization levels, and other uncertainties. The outputs might include the system schematic, an initial LCOH estimate, and a summary of the project's major development risks. At this point, we also know what needs to happen next. Perhaps the renewable resource data needs independent validation. Maybe the water source requires confirmation. Or perhaps the biggest remaining issue is securing an industrial offtaker. That is exactly what a development workflow should reveal. A useful hydrogen development package should answer 4 basic questions. First, what is the project story? What are we building, where are we building it, and what problem does it solve? Second, what is the technical logic? Where does the electricity come from? Where does the water come from? What electrolyzer technology is being considered? How will hydrogen be compressed, stored, transported, and delivered? Third, what is the economic signal? What is the estimated cost of hydrogen? What assumptions drive that result? And which variables create the greatest sensitivity? Finally, what is the risk narrative? What still needs to be proven before serious capital should move into the project? A strong H2Hub output should not try to hide uncertainty. It should make uncertainty visible. That makes the project easier to explain, easier to challenge, and ultimately easier to improve. This workflow can support several different types of users. For project developers, H2Hub provides a structured way to take an opportunity and develop a first-pass project case. For consultants, it can help organize early discussions with clients and identify which assumptions require further investigation. For investors and project finance teams, the workflow can help expose the questions that still need to be answered before capital should move. And for students, engineers, analysts, or professionals entering the hydrogen sector, H2Hub provides something that conventional courses often don't: the opportunity to learn project development by actually working through a project. The platform is particularly useful for people who understand that hydrogen has potential, but aren't yet sure how to translate that potential into a real infrastructure development pathway. There is also an important way to think about the platform itself. H2Hub should not be viewed as a random collection of hydrogen calculators and tools. The tools become much more useful when they are used in sequence. Start with the development problem. A hydrogen idea is not yet a hydrogen project. Then work through the project one step at a time. Use the same example throughout the entire process so that the site screening, assumptions, schematic, economics, and risks all relate to the same underlying project. This creates continuity, and it mirrors how real infrastructure development works. You don't build the financial model for one project, the schematic for another project, and the site assessment for a third. Everything ultimately needs to connect. That is the broader idea behind H2Hub, creating a guided development pathway rather than simply providing isolated tools. Every major hydrogen project begins long before construction. It begins with a question. Could hydrogen work here? Could renewable electricity support it? Could there be a customer? Could the economics eventually make sense? H2Hub gives you a place to begin answering those questions systematically. Start with one hydrogen idea. Screen the location. Define the assumptions. Build the system. Test the economics. Challenge the risks. And turn the results into a project narrative that can continue evolving as better information becomes available. The objective isn't to replace engineers, consultants, financiers, or developers. It's to help you enter those conversations better prepared. So instead of only studying hydrogen projects that other people are developing, start building the logic of your own. Visit h2hub.reneweenergy.com and begin with one project idea.